All right, so I hope everybody read the little warning up there, what we're going to cover today, and you've decided to stay here. I appreciate that. It is 5 p.m. after all, so we're going to go talk about stretch databases. Before we get started, how many of you attended the foundational keynote where Sean and Rohan did the demo and all but one little part worked? Okay, most of you did. Okay, hopefully this time all of it will work. So that's a fairly high-level overview. We're going to get into a little more detail today, but given that this is brand new technology, and this actually is the first time we're sharing with the public in a large setting like this. Even Microsoft internal staff in our field have not been presented to. So we've shared this with some of our close partners who are in our database advisor groups. We've shared this with the MVPs, and we've also spoken to a number of analysts and industry analysts, but we've never actually shared this publicly, including Microsoft Field. So you guys are the first ones to see this. So you might go back to your field guys in Microsoft and say, hey, do you know about this? Maybe I can show you a thing or two. So this is our agenda for today. We're going to look at the current landscape and basically give you an idea of how we landed with this StretchDB thing. I know Sean described some of the experiences he had talking to customers and how they started brainstorming on this, and then we got this into a full-fledged project, and we got scenarios defined and features and so forth. Really important thing, what is the stretch mindset? I know this is kind of odd. This session is listed under cloud and hybrid, although we're really working off SQL Server, and we're stretching to Azure. Currently SQLDB, but we potentially will be somewhere else also. It's really important to differentiate the stretch mindset versus what most hybrid scenarios today are talking about, which is move big chunks of stuff over and figure out how to repoint things and all kinds of fun stuff like that. I used to work in a data movement team, and we did a lot of that, move large amounts of data, migrate your database, and that's perfectly fine. It's a good thing to do, but it may not be the right thing for you, especially if you can't move your applications or you can't modify your applications. And of course, then we're going to figure out how it works. So before we get started, a couple of things I'd like to find out from the audience. First and foremost, how many of you consider yourselves DBAs, or you have to play the DBA role willingly or forced? Okay, good. Majority of DBAs. Developers in here. It's okay if you play multiple roles. Okay, we got quite a number of developers. Other IT admins, Windows SAN security admins, storage admins. Excellent. Brave men, raise your hands really high. Great. Business decision makers. 1, 2. Oh, we got a few of them. Excellent. Okay. I kind of wanted to get a feel for that to see where folks are distributed first before we ask the next question, because this is one of the things that actually drove us to think really hard about how to make this better. Sean Bice earlier talked about how we can significantly reduce the cost and make things easier. So all of you here, when you think back, the DBAs especially, and I used to be a DBA in a previous life, what do you think about when you think about your current enterprise storage or your entire history with being a DBA, when you think about your enterprise storage or your SAN experience? Where would you number yourself? Shout outs? Anybody want to volunteer? Just go ahead and shout. I won't look at who said what. 5, mostly? No 10s? You guys are too polite. Maybe we should serve beer in here before we get started. Anybody have to deal with this? Being told that you DBA guys and gals are consuming way too much storage and you guys got to cut them down by a certain amount? Do you know what your dollar or cost per gigabyte per month is? We've spoke to a lot of people. We've also have these numbers tracked internally within our departments. One of the common things we've found is most companies do not know the accurate numbers, and the ones that do are typically accounting for only the hardware and the maintenance and the software. And when we ask them, what about your DBA's time and the fact that they have to stay 18 hours to go recover stuff, and they look at that and say, well, they're employees. So, and you can replace employees with some other words, but effectively that was the tone that we got, and it's rough. I know what it's like. I've been there. So think of this, and this is a fun one. Think of your largest OLTP database, not your DWs, not your big old relational DWs and whatnot. How many rows do you have in your largest table? Volunteers, anybody? Sir?
Yeah, 380 billion.
OLTP database. Did you say 380 billion?
Yeah.
Okay. One table? Or do you partition?
Currently, we are doing partitioning, yeah. So
Okay.
I'm helping a customer doing this stuff right. So
Okay, I feel a little better when you have partition. How many partitions?
we actually are doing 10 for 10 years back in time, and then we are doing months, and then we're actually doing weeks for the current week, and we're actually doing days for the current day in the current week.
So probably in tens of thousands of partitions.
No, that's not that many. We merged them together, so the previous years are years.
Okay.
So I'd say like
Oh, so it's
25, 40.
40 partitions? That's still a lot of data. 380 billion rows. Okay, you take the cake, but you got partitions. Others? Anybody want to volunteer? It doesn't have to be bigger. You don't have to one-up this gentleman here. You know, you get a bunch of technical people in the room. They're like, well, you said 380 billion. I got to come with... Somebody else? Sir?
1.2 billion in a single table.
Single table. Excellent. 1.2 billion single table. Anybody else? Anybody want to top that? 1.2 going once? So these are common numbers. When we started out with this, we thought 1 billion rows per table unpartitioned would be a good target to go after. After meeting with the analysts and some MVPs, and we realized, actually in an MVP room about this many people, and we asked how many of you deal with tables with 1 billion rows or more, and more than half the room raised their hands. So 1 billion row apparently is very popular. And as we have other meetings with customers, and we ran a design review with a number of enterprise customers that are in our advisor groups, we asked the same question. And then there's people at 1 point something, and another 2, and another gentleman says, well, I've got a table with 6.5 billion rows, one table not partitioned. So for single table unpartitioned, that's the highest I've seen so far, but 380 over about 40 partitions, that's still a lot of data. So I won't ask you how much fun you have with reindexing. So if you have your databases, and I said I want to ask about indexing, what about your backup and restore performance? So if you have partitions, you have the ability to say, yeah, these things are read-only, and I move things out. But if you don't, if you're stuck with a single table, if you have 1 billion rows, or if your billion row table is several hundred gigs or terabytes in size, as the gentleman we spoke with before, 6.5 billion rows that are running into terabyte-sized tables, when you need to do a full DB restore, what happens? You restore all the hot data that you care a lot about to bring your business back online, and you got to wait for the cold stuff to come back online, and you have your CXO, whoever it is, tapping on your shoulder. Is it done yet? Is it done yet? I went to TechEd last week, or Ignite last week, and I saw this really cool thing that it can do fast restore. You know, maybe I should show you how to do that. And you're sitting there at the DBA saying, you know what? If you approve my SAN request so that I have more throughput and better I/O, we would be done already. So that's not much fun to go do, and those are some of the motivations we had. We wanted to make life easier for our customers. So the current landscape we're looking at really is what we just kind of described. A lot of users we talk to want to retain cold data, and the cold data could vary by definition depending on where you're coming from, and they want to retain that indefinitely. You ask the business users, they're saying, well, I don't know when I'm going to go ask this question, but I want it to be ready. One of the common examples in the financial services. I had a customer who came and took a loan from me X number of years ago. And the next time this person calls me, and you know, they had a good experience the last time, I want to be able to say, Mr. So-and-so, I remember you from blah, 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 and yeah, you're still staying at this place. How do you like that? Okay. They want to be able to have those conversations very quickly. When auditors come knocking, when a fraud investigator comes knocking, you want to be able to get them that data as quickly as possible, especially if they want to investigate something that happened years ago, but the employee may not even be here, and you would have archived that. Most archive solutions today including some of those that cost several $100,000 to implement, would set your data in a different application, a different database, or in some cases, your archive solution is putting stuff into tapes, and you put that tape somewhere else. The next time you bring them out and try and restore them, you hope they actually restore. That's both challenging in terms of getting these things to work correctly every time, and even when it does work correctly every time, you're talking at least minimum minutes, many minutes, to go to a different application, fire it up, pull data, bring it back here, or hours to days before you get to that data. And users are not particularly fond of waiting hours or days. DBAs have to deal with the size, have to deal with maintenance, and really that's the worst part. How do you go about doing performance maintenance on these billion-row, multi-billion row tables? It's extremely complicated, and in many cases, you just can't. We have a lot of customers who don't even back up their databases anymore because they're running to the tens of terabytes. It just doesn't make sense. You just make copies and copies of that. So in the event of disaster, you would just go to a snap copy as opposed to try and restore because they just can't back up enough within the allotted time window so that they would be able to recover within the SLA. It just doesn't work. And the challenge is users won't tell you, or they dare not tell you, which data you can truncate or remove because they'll say, well, I don't know if I'm going to go ask this question later. What happens there? So that gets into a situation where you're really paying for your local storage and you optimize for performance up here, but the challenge is you have to pay a fairly high cost in both hardware and maintenance and your software licenses, and also you pay a high admin overhead. So that's the little triangle that we have. What we're proposing, and this actually illustrates where we see a lot of users saying keep everything, and the storage admins and the budget owners saying cut, get rid of everything. True story, we have a lot of customers who actually truncate or delete their tables on a regular basis because they just cannot keep up and they cannot acquire new hardware. Embarrassed to say, there are divisions even internally in Microsoft that do that. Our TFS databases get into massive amounts, so if they exceed a certain number of years, we truncate those things. There's a hospital, I won't tell you where, not in this country, that actually truncates or deletes data older than 2 weeks because their systems cannot keep up with it. The incoming rate is just so high, they cannot keep up with stuff. They will not keep records in a database older than 2 weeks. Basically, what they do is there's a printer room with lots of printers, and they continually print all this stuff out, and then patients will get copies of their stuff, and anything older than 2 weeks gets truncated. So if you happen to be staying at that hospital, try to recover within 2 weeks, beyond the... This is real because you will see patients walking around with stacks of paper because they just cannot keep up. And that's just reality. And when we ask all of these customers we talk to, is that data that you truncate useful? Some of them say yes, some say no. Most of them say, we really don't know, but we got to do this. Otherwise, the system falls over. So that's kind of a bad place to be, especially for DBAs. So with StretchDB, what we're really saying is there's a way to leverage stuff transparently in Azure. And we want to make sure that we make it as transparent as possible. We know it's not going to be 100%, but we're going to get pretty close. What you're going to trade off is a little bit of perf and latency. That's what we're hoping will work for folks. And obviously, your perf and latency trade-off will vary depending on what your network infrastructure is and what subscription you have in Azure. But you can bump subscriptions up and down as you need to, depending on what loads you expect to run. The key thing here is we want to make it extremely easy for you to implement, extremely easy for you to maintain. So those are critical things. And we want to make sure that you understand the stretch mindset. So this is really important. All of that stuff when we talk about, we want to make it easier, make your life better. It's only possible because we're thinking about this from a stretch perspective, not from a let's load a big chunk of data and move your database to Azure kind of deal. So imagine you currently have your on-premise server and with the hot data, which based on analyst conversations and actual customers and our own internal systems, you're anywhere between 70 to as high as 85% of cold data if your database has been running for many years. And what we're saying is we have the ability to trickle cold data. You tell us what's cold data. We trickle that in the background. It doesn't interfere with your operations. You can define that at any time. All the operations are online. And we move that in the background to Azure. while you're up and running. Queries are not affected. Users will not see it. We will make sure we abide by resource governor rules. If you want to set up RG against the data movement, that will be possible. We're also exploring potentially setting up schedulers so you can control and tell us when we can or cannot move the data. I understand there are some geographies where you have variable rate pricing for your telco. So certain times of the day, it's cheaper for you to consume lots of network bandwidth going out, and other times it's not. Or maybe you got busy times in the day, and then in the evenings you want to max the movement so that way you don't interfere with users. We're thinking of all these various options, but the key driver here is it's got to be trickle and transparent. It cannot bother the users running live workloads. So if we can do that, what effectively happens is your business applications will continue to work. Your queries continue to run. You don't go out there and make changes to query. If your table can stretch, then chances are your queries will continue to run, and we will try and make it as efficient as possible. We probably won't get to every single type of query, but the more customers that get on the beta and give us feedback, the better we'll get at this. DBA scripts, this is really important. We want to make sure our DBAs do not have to go out there and retool their management scripts, their monitoring capabilities. This includes third-party tooling. So we want to work closely with ISVs who provide management and monitoring software so that you don't have to go, oh, nuts, now I got to go buy something new, or I got to go write a whole bunch of scripts to go figure out who are my top blocking queries or what are my worst performing ones. No, we got to make sure that all these things work. We just may provide you additional data that you need to learn how to consume. And of course, developers continue building that. As far as developers are concerned, they don't need to know that there's stuff stretched back there. They use the same frameworks, same tools, and they would use the same APIs. They don't have to go figure out, oh, well, now there's a table that's partly over the other side. How do I write a query to do that? No. If you have a query that says, pull all the data back from this table based on this time period or based on this criteria, the same thing will apply. So if you want to be smarter about it, and this is some of the future work we're thinking about, maybe we want to figure out how to just push queries that are intended for the archive data strictly offsite, and we find a way to directly access that as opposed to going through the local engine. But that's farther down the pipe, things that we're going to explore once we ship 2016. But for now, the key thing really you got to remember is DBAs retain full control. Everything is still done locally. You control your ACLs locally, your permissions, security settings locally, you control the user access. All of that stuff does not change. Users don't have any means or ways to get to the data on the Azure side unless you are a sysadmin. And even then, we're looking at how to lock down even for sysadmins using Azure RBAC. And there's still chances that there's a rogue subscription admin that may go in there and do weird things, but we also have ability to track that by turning on SQLDB audit in Azure and setting your audit records to a different subscription. You can actually keep track even if the subscription admin, that's like God on the Azure side, and we can track that they did something, and you can keep that audit in a different subscription, so this person will not be able to go muck around with stuff and get away with it. But all regular users below this subscription admin will not be able to touch the remote data. DBA still retain full control, everything locally. So, how does it work? So most of you went to the general session and looked and saw the demo, and Rohan showed you that pretty wizard from Management Studio. So I'm going to show you very quickly what that is, but I also want to show you what things look like in T-SQL. One of the things that we set as a criteria for shipping this feature is we've got to make sure that everything that we do can be done via SSMS GUI interface, also via T-SQL, and also via PowerShell. So I know a lot of folks here are deeply into scripting, either T-SQL or PowerShell or both. So we want to make sure we support all of you. And really, when you have large enterprise systems, scripting really is the safe way to go. You want to be able to see the exact thing that's run, and the same thing gets run consistently. So we will make sure we all have rich support for that. And that way, you guys can continue with your current patterns and not, oh, I got to do this, now I got to go chase the mouse around. So if you don't like the GUI, T-SQL works fine. If you like the GUI, fantastic. We're going to make that better. I know SSMS is kind of old. It's been around for a while. But they're going to revamp that and make that better. The current versions you see has not been updated yet, but do expect improvements in Management Studio also. So we're going to look at how it works. We're going to look a little bit into data movement and how a table gets stretched. We're going to look at the queries, and hopefully we'll see the remote query operator. And of course, we'll look at backup and restore. And I'm going to switch back and forth between demos and some slides. So we're going to show you what to do and how it's done, and then go back to the slides with some architecture diagrams to explain what actually happened. So let's get started with one of these things. Okay, so here's your Trustee Management Studio. Is the font visible? Do you guys need me to bump it up a little bigger? You're okay? Excellent. So as you remember, one of the first things we want to do is turn on SP Configure, as Rohan described. So if you, well, I don't have this here, but let's go ahead and do that. And if you check a little farther down the rows, there's a new entry called Remote Data Archive, and I've already turned it on to 1. And as mentioned earlier, we want to make sure you still retain full control. In large environments, it's very common to have DBAs, basically the instance or server level admin. And then you have application owners that are essentially DBOs that own the databases beneath that. And we want to make sure DBAs still retain full control over what instance, which servers can or cannot stretch to Azure. And then the next layer down, the DBO will then decide whether or not my database, because I could have schemas in there also owned by different people. I could have an ERP database that's got the accounts and sales and HR schemas all owned by different application owner, different departments. So at the database level, I can then say enable or disable stretch. And if I enable that, then the individual application owner, schema, table owners can then go stretch their stuff. And if something terrible happened or you suspect something terrible has happened, DBAs can go in there and flip the switch on SP Configure, and we shut the instance down. We can't go out there and touch the remote stuff anymore. So that way you can go investigate, is this the culprit? If not, then we can turn people back on. So we give a lot of control, and we make sure that if something terrible happened, you know, it is the internet after all. So you have an ability, this is kind of like your break glass. You flip this on, it doesn't break anything. Your databases will still be as is. We don't remove any configurations. We just basically stop all activity, all calls to stretch-related commands and APIs will be prevented, and nothing will get in or out. That way you can go figure out what happened and fix stuff and then turn it back on if things are okay. So let's look at this one database we have going here. And I've already stretched a couple of tables just so that we have some data to go look at on the remote side. So we introduced some DMVs and catalog views, and we've also updated sys databases and sys tables to give you additional information about what's going on with StretchDB. So right now, there's no activity going on. This basically will tell you if there's been activities, if rows have been stretched and move on, then you would see this getting populated. And we'll come back to this a little later. And if I look at the database level, you'll notice there's one entry in there because I've already enabled a database for stretch. Now, if I look at the table level, I also have a table that I enabled earlier for stretch, and it will show up here. So you have ways to, so if you have management tools, you use SCOM or whatnot, or some other HP, OpenView, whatever it is, that you go send agents out and you go poke into databases to see if people have done things they're not supposed to, you have access to all these views to make sure that you know exactly what other folks are doing. You may be central IT. You can poke into departmental ITs to see if they're doing stuff they're not supposed to. So let's go ahead and look at some data that I've already stretched. So to stretch a database, there are a couple of ways to do that. If you went to the earlier foundational keynote, you would right-click on one of these databases. Whoops. Let's see, have I stretched any of these? Task. And you basically will have the wizard that you would drive and say enable or disable stretch. So I've already stretched this, so the disable part is grayed, the enable part is grayed out, but I've paused this, so you can't disable or enable right now. But if you're using a new database, you will have the ability to run the wizard. It's very straightforward. Actually, I can show you just create a new database here. And, oops. Let's execute that. So now I've just created a new database and I've enabled SP configure to let it stretch, and you can see it says now I can enable database for stretch. And just very quickly, if I need to, I'll sign into my Azure account. And I am remote desktop into CorpNet, so it will not prompt me for the phone signing. Hopefully not. I don't remember my PIN. Okay. Okay, good. So our security is set up such that if we're trying to log in off CorpNet, our corporate network, then I will have to go through the 2FA authentication over the phone. If I'm on CorpNet, then I don't have to do that, so which is good because I don't remember my PIN. And essentially, you would go decide where you want to stretch it, which locations, and provide what's the name for your server admin and the strong password, and hit finish, and that's pretty much it if you want to go through the wizard. Or if you're pretty hardcore, let's go cancel this, or if you like scripting, there are a few things you need to do. The first thing is you would create a credential, and this is the credential that we are using to connect to the SQL Azure database. So remember earlier I had to sign in, so this is essentially a credential that you would provide that would connect to Azure SQL DB, and you would then go ahead and run alter database command. This is something that you're all familiar with, and we'll point to the server equals whatever credential name you created earlier, and this would be the full server and the domain name, so the full four-part name to it. And all we got, whoops, reconfigure doesn't belong here. And once you run this, then your database is enabled for stretch. And that's where you get the result, and you can see that. So we've effectively enabled the database for stretch. No table has been stretched. We didn't actually go out there and stretch any tables. Now let's look at two that I stretched earlier. These are two identical tables. One order details history local, and notice you have order ID 1028, blah, whatever, and you've got 2155 rows. And if I did the same thing for a stretch table, and it took just a split second, it's a very small number of rows, so it ran very quickly. So the same table, but number of 255 rows. Oops, I should have shown you this execution plan. Yeah, this is the part that my engineering manager, unfortunately, the network reset on him, so he couldn't show you the remote execution plan. So this is the local only, nothing interesting. It's just a simple table scan. And if I did the remote, the stretched table, you will see it's learned that the data is remote. So what we've done is we've taught the query processor to understand the difference between data that's local and remote, so that you don't have to go figure out and start changing your queries and say, this stuff is here, go do a join on the remote side. We effectively rewrite the queries at the algebraizer level so that when the queries come in and we look into metadata and say, this is a stretched table, and then we look at, okay, well, what are the predicates they're going to use, and we make intelligent decisions on what parts of their original query to rewrite and farm out to the Azure side, and then what parts will be run locally. So you don't have to go figure this stuff out. So So the question is, do you only run the stretch up to Azure, or do you stretch to other cloud providers? Today, we only stretch to Azure SQL DB. SQL DB is currently our placeholder. The business people are trying to figure out what the right SKU or model and stuff is. So on the engineering side, we effectively have a storage and compute capabilities on the remote side, and SQL DB is our first target. There's nothing in our architecture that will prevent us from stretching other places, for instance, stretching to another SQL server. It's just that this is our first landing point, and the way we've architected this, we can easily go implement on other stuff, but we need a V1 first. So if I do a quick count there, we verify that both of them come back 2155. Now, if we want to look at stretch status, there's a bunch of things out there. As we saw earlier, we're not going to look into it, the dynamic management views and so forth. Let's go ahead and create a new table and see how we actually stretch a table. So create a new table. Whoops. Ooh, that's not good. Let's see if that worked. basically a simple select into to create a new table. Okay, so there's something there. Let's go ahead and delete some stuff from this. Equals 10248. Okay, so we get that back. So the original one had 1024, and if you look at the earlier examples we had 10248, and then the current one with deleted 10248. And if we look at space use, you notice there's a new parameter we have in there where we can say local only, and we also have the ability to say all, or we can say remote only. So that way you can run space use and figure out how much of the data resides local versus remote, what's the distribution, because if you just stretched a very large table, this could probably take a while, and we give you the ability via views to see the status, is it still actively stretching, but we also tell you how many rows that you have pending and so forth. So now if I enable this for stretch, this is the command that I would enable a table for stretch. So it's fairly straightforward, alter table, enable remote data archive. Some of these names may change when we get to RTM, but the syntax won't go very far. So enable that, and migration state equals on. So you notice there's a difference in enabling for stretch versus migration state. So migration state basically says you want to continue moving data, or maybe something weird's going on, or maybe you're having network congestion, you want to pause that, you can say enable stretch, but migration off so that data movement does not occur. So you still have full control over what we do here, even though I say we trickle stuff in the background. You can stop us from trickling if, for whatever reason, you need to do so. So I'm going to go ahead and enable this, and it runs. And earlier we ran this, we saw only one row, so we give it a few moments. What happens is we actually have a background thread that basically wakes up every 15 seconds, and this is something that will be optimizable. It will figure out if there's lots of work, it will wake up more frequently. If it's not, there's not much to do, it will sleep longer and so forth. It will wake up and see, do I have something to do? If I have something to do, I'll go pick it up, and if it's to move data, I'll move data. If it's to create a new table on the remote site, I will go ahead and do that. And if I go run this again, you see a second row pop up because the one we just stretched, if you look out here, this is what we stretched earlier, and this is the Ignite orders that we just created and stretched. And if we are quick to run this, we might see, okay, it's already moved across. So the number of rows migrated tells us that all of the stuff that we created earlier, 2152 rows, remember the original table had 2155. Now, this new table we created where we deleted 3 rows has also just migrated over. And if I go back to the query that we had earlier, oops, let's make sure we don't accidentally run this guy. Stretch. I didn't change nothing, same query, but now you notice the table we just created automatically had a remote operator, and if I go over to SP space used and run local only, notice I have no rows left locally because all 2,000 some migrated over to Azure. So that's the data movement part. So let's go back and cover a few of the slides that we have here to reiterate and make sure we understood what happened. And okay, we are good. So we started off enabling stretch database, as mentioned before. The first thing you do, SP configure, make sure you turn it on at the instance level, and then you would go stretch it at the database level. And what we do is we establish a connection with Azure on the remote side. Now, this is important. Some folks, when they first looked at this, they asked us, this kind of looks like Store Simple. Why don't you just use Store Simple? Life would be easier, right? Not really. We're a database. We're not files. If you use a solution like Store Simple, it would actually make our lives a whole lot easier, except it will not make your lives any easier, because when you need to pull data from the remote side, you don't want to pull all of it every single time, because otherwise, how would you process your predicates? So we need compute and storage on the remote, and something like Store Simple will not work. Question, sir?
Does it work with files being in the table on top of the file
So the question is, does it work with file stream tables and tables on top of file streams? The architecture, there's nothing that prevents this from working. We're evaluating, do we want to support that? Because if you have file streams sitting on a remote, essentially you have all large amounts of blobs sitting remotely. What is your performance going to be? How much are you going to pay over network transmissions and stuff like that when you're transferring blobs? We actually started out investigating that scenario because things like SharePoint, for instance, tend to have lots of these blobs. TFS has the same thing. And we figured, hey, maybe people want to keep their SharePoints for 50 years. I don't know, any SharePoint admins here? People nodding their heads, really? 50 years? People get mad and they go back, hey, I had this thing in here from 7 years ago. Where did you put it? And so we've seen that. So we did investigate that, and we know how to do it. But we just figured, customers would probably be wondering, yeah, if I put all the blobs out there, if I need to retrieve a whole bunch of it, it might take my network down. So we're optimizing for relational character-based data for now, but the design actually does work for blobs also. So as for file streams specifically, right now we have it locked down, but that's just because we want to make sure that we have it properly tested, that there's nothing preventing it from working technically. We just lock it down so that customers don't accidentally stretch large amounts of blob data, and then they take their networks down. So
That's the use case I'd be interested
talk to me offline. I'd really like to understand what that is. Thank you. There was a question here?
Quick question. How do the stretch tables handle indexes? Like, does it have an index on it? Like, if your original table before you stretched it had an index, does it carry it over to the stretched area? Or does it treat the table as a, just as a hash table, pretty much, or, just a heap table?
Okay, so basically, how do we handle schemas and indexes? So let me walk through the next slide, and then tell me if I did not answer that question. So when you enable the stretch, the two scenarios that we're going after in V1 is the case where you already have an archive table. We know some customers already have this pattern. Some ISVs have this pattern. They have a table that's dedicated to archive data. They have their hot data, like order detail, and then there's order detail history. And they already have a process, stored procedures or SSIS packages, that periodically would grab all of the data that's old or closed business data and move it to the history table. So that's a typical archive table scenario. And the second scenario that we support is you just have one giant table with hot and cold data mixed in there. And so long as you can tell us that this is cold data, for example, any data older than 6 months or any data older than 7 years, if you work with tax departments, you want to keep stuff close by when the IRS comes a knocking, and then stuff beyond that, well, if they come for data older than 7 years, you can probably tell them bye-bye or have them wait for a little bit. So things like that, if you can tell us what the cold data is, then we will stretch that for you within the same table. So these are the two core scenarios that we support for V1. And what happens is when you tell us that these are the tables you want to move, we create the schemas on the remote side for either one of these cases, and we basically have the trickle data migration that I talked about earlier. As you saw, I enabled the table for stretch, and it took a few moments, and the thread woke up and picked it up and say, let me go ahead and create the schema. Let me go ahead and start moving data across. And we'll move both of them over. We move your indexes over, and we will recreate on the other side. But that's really not the interesting thing. I think what you really want to get to is eventually when I have a lot of data, and we see customers looking into tens of terabytes on the remote side, I don't query that very often. But when I do query, I probably don't want it to take a really long time. So I want to be able to have indexes on the remote side so that it makes these complex queries on the cold data run better. But I don't want to pay the penalty of maintaining the indexes on my OLTP on the local side because I don't run these queries on these OLTP local side. Only when the auditors come in, I need to run that. So what do? Well, we're going to make sure that we can support schema drifts so that you can have schemas that are no longer the same from both sides. And we're going to allow you to be able to optimize your indexes on the remote versus indexes on the local. We're also going to be clever about index maintenance. So if you did a DBCC DB reindex or an alter database, alter table reindex, we want to be clever about this, right? Data out there, for the most part, is immutable. You're not going to change archive data unless something unusual happened. That would be considered an administrative function. So if data is immutable, it doesn't change, why would you go burn CPU cycles, go reindex that? So we want to be clever about how we handle these types of operations. If you tell us, go do reindex, we'll make sure the local behaves correctly as you would expect it to. And then on the remote side, we will make a determination on whether it's necessary to run that. If it's against, let's say we have multiple shards of databases out there, and once we've closed it off, the data will never change again. We're not going to run that and burn CPU cycle. I mean, we could, it's nice. It's your Azure subscription. It's more billing, but you're probably going to be pretty mad at us for doing that. So we'll play nice. We won't run that. That way, you also will not pay for CPU cycles that really buy you nothing, which is pretty hard to do today. If you had a very large table, you can't say, oh, just go reindex the stuff that hasn't changed. Unless you've got partitions, as a gentleman here, but then you got to be pretty clever about setting up partitions and maintaining them. So it's a trade-off. So transparent remote access, as you saw earlier, the same query runs exactly the same way, and you can do joins, and we want to be clever about making sure that we push the predicates down to remote. Another reason why having a regular store, whether it's Azure Blob Store or Store Simple, will not work, because we want to be able to push predicates down to the remote side and bring only whatever data that meets the predicate and bring it back to join with the local. Otherwise, every time you need to go to write a query that has any kind of where clause, you end up scanning and pulling all of that stuff. If you have several hundred gigs, that's a really bad scenario. If you have terabytes, that will be, you basically DOS yourself. So that's not a good thing. So this is how the query works. When the local-only query comes in, we're smart enough to figure out that all of the data resides locally. The QP will make that decision and only farm the query out locally, so we don't burn Azure resources to go find, oh, do you have stuff out there? Oh, nothing? OK, fine, we'll come back. So we try to be pretty clever about that. And if you have data that covers both local and remote, we also farm that out automatically, bring it back, and reassemble and send it to you. As far as the application is concerned, it's one table, one SQL server. I have no idea, and I shouldn't care that it's going out there. We need to do the right thing so that you don't have to worry about it. Now, next thing what would be interesting is what happens if something terrible happened. So let's go back to the demo 8. And I've got a much bigger database I've set up. OK, so this is a slightly larger table, and it's nowhere near what most of you have. But if I look at the database size, let's see, am I in the right database? Picking at me, OK. So it's several hundred megs, but this is running off a workstation under my desk. So it's, things that DBAs really hate. You have databases running under somebody's desk. But this is my dev machine, so that's OK. And don't get mad at me. Now, we have a table, space use. It's out here. And I've already set this up for stretching. And it's been going on for a while. It's been migrating rows happily for quite some time now. As you can see, it's been going on and moving data happily out there, 10,000 at a time. Oops. Yeah, let's go ahead and pause migration for a second. All right. So I've already backed up this database earlier. Let's take a look at, let's see, I got space used. Oh, well. Let's do a select count on this. Nothing on a local, but what do we have when we do? Oops. It should be about 2 to 3 million rows. I've let it run for a little while using a little script loop. So essentially what happens is you're looking at a database that's about half a gig, about a gig in size, that's running on a machine under my desk, and none of the rows actually reside locally. So the bulk of these rows, since the stretch has been running for a few hours, all of these rows have moved over to Azure, and I really have effectively nothing here. So this should be under a minute. We'll give it a chance to complete. So I backed up the database earlier, so we can go ahead and try and do a restore. OK, 300 million rows, so let's go ahead and pretend that somebody decided to go unplug your server, and you had to do a restore. And let's turn this to single user. Okay, that's the database. And let's go ahead. Whoops. All right. And restore that same database and see how that plays out. And hopefully it plays out. Okay, so it took a whole 4 seconds to restore the gig, and you can say, well, that's a gig. Well, try restoring a gig on an old IDE drive workstation and see how long that takes you. And the other key thing really here is, remember we talked about we're being smart about making your lives easier with backup and restore. And so how does that work? We managed to pull that back. Oh, by the way, we should go look at the data. So if I try to go back and run that select again, should have just copied this down. So if I do an SP space count again, SP space used again on the same thing, whoops, what's going on? Use database. You guys weren't paying attention, were you? All right. Let's try that, and let's try and count that. Okay, still nothing local, so let's go and see if we can count this puppy. Okay, that worked. Let's go and try and select that. Or the history stretched. Well, what happened? I restored it. What happened to my data? Count 0. Well, that's a terrible thing. So what happened is, remember we talked about making sure the DBAs retain full control and making sure that you have the security is a critical part of a stretched database. So upon restore, we require, and this is the default behavior, we require that you go back and reauthorize this database to connect to the Azure part of your remote storage. And the reason, there are multiple good reasons for that. The main one really being you don't want some random person within your organization to be able to go take a backup of your database and go restore and now connect to remote data. And this person could be sitting somewhere in a different department. A lot of companies that we've worked with, and unfortunately they still do, backups go to a shared location that's not secured to the department. It's shared by multiple departments, and people can go look at backup files sitting out there. If you're clever, you know how to browse or you know how to search, you'll find them. And people randomly go do database restore and pull stuff. And in some cases, pulling customers' historical data could cause you significant amounts of grief. Other things would be somebody that's malicious that wants to go steal a backup of your database, and that happens, unfortunately, quite often also. And I'll go back and I'll set up a VM, and I'll go spoof your domain, spoof your IP addresses. Those are really easy to do, and spoof your instance name, all that fun stuff. A disgruntled employee maybe, go grab a machine that's already synced with the domain controller, and you would even have actual credentials and try and connect. Well, you can't. You need to be the authorized person, and this authorized user today, it's running SQL Server auth, but moving forward, we will support integrated auth with Windows Active Directory. That way, you don't even need to provide the user ID and passwords. It will just actually take your Windows creds and connect to SQLDB and either authorize or let you perform operations. So in this case, I'm going to switch out here a little bit, because I know my colleagues have done this before where they publish passwords in the middle of demos and conferences. So I'll try not to do that. So let me go ahead and run that command. Yeah, you guys laugh. So the question is, if you restart the instance, do you have to reauthorize? No, you don't. But we're thinking of, do we need to lock that down? So you should maybe tell us, because we figure so long as you did not lose or create a different copy, we actually have a mechanism in the background that actually helps us keep track of which is the primary instance and which database you're looking at. So if you restore a database, so you've effectively revved the counter for that database copy, so that has made a change that we track. Or if you move the instance or something else, if everything stayed the same, the database did not rev the copy counter, and the instance is still the same, you didn't move it to a different machine, different instance, nothing has changed. Right now, the default behavior is we don't, but if you guys feel like, nah, that's not secure enough, we want to make sure that you reauthorize even with that. That's a fairly easy implementation for us. And bear in mind, all of these things are, we're talking about default behaviors. We'll also make sure that you can set a different default for your environment, or you have the ability to script it out so you don't have to go follow these things every time. So we understand the need for security, but we also understand that there's also a need for making sure things aren't a pain in the butt to go use. So I've go ahead and reauthorize that successfully, and keeping fingers crossed this actually works. So it works. So these are the little things that we pay careful attention to. Hopefully, it'll make your lives easier, and you don't have to go answer to some security review or management saying, oh, how can you put stuff in the cloud? Well, we support the encryption capabilities that Always Encrypted brings. We also make sure that DBAs still retain all control locally, so that if you don't like something, you can stop it or you can bring it back. So all of these things hopefully will make it easier for you to figure out, okay, I can now solve these big table problems without a whole lot of grief. So how do we do that? Your regular backup and restore, as mentioned earlier, you got to do restore for both your hot and cold data, and you wait for that to complete before things come online. What we do is, with StretchDB, we back up all the stuff that's local. After you've stretched the table to remote, we back up all the local database content, just like you normally would. There's no difference there. But the good thing here is, because your local has shrunk significantly in size, your local backup will be faster also, and it consumes less storage. So that's another plus point. And what we also did is we modified the backup command, so we take a little bit of metadata on the StretchDB portion, so we know that this is a stretch database. There's stuff it needs to connect to on the remote side, and we know where it needs to go point to. We know which remote target it is. If you open up Azure Management Portal, you will actually see these objects, and we basically manage them and we lock them away, but you can see them if you have the appropriate permissions, so that way you know, I've got all of these things stretched by this department or that group and whatnot. So we keep that metadata locally during our backup, and upon restore, we lay all of the bits down locally on storage, as you would expect a regular restore would do, after which then we will wait for you to issue that reauthorize command. And once you issue that, we will look in the metadata and say, okay, this is a credential. Let me go connect to Azure and reestablish that metadata update. So it will typically take about 20, 30 seconds. If your network is congested, it may take a minute, but it doesn't matter if you have a gigabyte sitting remote or you have 20 terabytes sitting remote. It's a metadata operation. So the other really cool thing that we're working on also is to take advantage of Azure Snapshot backups. So think of the scenarios where you want to be able to provide your dev test environments with either a local copy, or you want the entire set of data so that they can do some serious testing. Well, you can take a backup of this stretch database, and you can restore that local only, so it has no ties to the remote, and the developers can do functional tests and whatnot against just that local copy of data. If you want to do a full end-to-end test, some kind of hardcore stress testing, then you can enable it to connect to either a copy, which probably not so cool. If you've got 20, 30, 50 terabytes out there, you're going to be burning a lot of cycles just copying data out there. But with Snapshot, we can basically do a restore of a snapshot backup, and all it's just going to do a snapshot restore, and you would basically have pointers to the original one, and it will be read-only, but if your tests are non-destructive, for starters, we don't modify archive data anyway, so read-only is kind of a moot point, but you get to snapshot 50 terabytes in a matter of minutes, and your dev test environments now has both local, whatever size you have, and the remote, whatever tens of terabytes that you have, in a matter of the time it takes to restore local. So we make life a little easier for you in those environments also. And certainly with the scripting capabilities, you can automate a lot of that and lock it away so that if it's authenticated and authorized via your AD accounts, your Windows Active Directory accounts, then you don't even need to go keep any credentials or passwords. You basically create security groups and say these people can go ahead and run the store procedure or run the script, and it will automatically go do this work for them. What was the question?
So let's say if you decided the cold data is of 1 month, so the data moved to Azure. Then when you had a request and restore the database back to 1 month ago, how I know you have backup here, only backup local, data. How the Azure to restore the backup back to 30 days ago?
Okay, so the question is, let's say the user wants to restore to last month's version of the backup. Something weird happened in between, and you want to go restore back there. So when we move data across, we actually maintain versionings of that using an internal batch ID mechanism. So we keep track of your database, actually you're at a table level, so we know which rows have what transactional consistency at which time stamp with your local. So by using that, when you say restore back to time X, we would go back and look at our batch ID implementation and look at that time X corresponds to this batch, and you will be able to restore to that point in time. And after that, what we basically do is we mark the other stuff as non-visible so that you won't be able to see, well, what's this weird stuff that I never knew existed because it was from after your backup. Now, if you look at that restore, let's get to a more interesting scenario. If I restore to last month, and you're like, oh, nuts, that wasn't what I really wanted. And, okay, maybe you're good DBAs. I used to do that. And I was like, last month, oh, nuts, that's not it. I need to go restore from last week. And I put that in there. Oh, crap, that's not it either. I need to go restore from 2 weeks ago, not last week. So I jump back and forth with that. So the same mechanism applies. We make sure that we know where you're coming from locally. We look at the corresponding batch ID timestamps, and we basically hide the stuff that you can't see. And whatever that you restore on the local side, we just make sure that metadata update will point to the right place and mask the right stuff. And that way you can jump back and forth like you do today. But the cool thing is, if you try to do jump back and forth using a 10 terabyte or 20 terabyte or even 1 terabyte database today, you'll be taking a lot of breaks. Go for a coffee, come back, oh, not done, another coffee, you come back. In this case, you'll be done in a matter of anything on the remote side, about a minute. Local, well, whatever you have local to pull through. So if you have these historical versions that lay for extended periods of time, we will work on garbage collection and cleanup over time so that when the backups expire, then we figure out how to clean up stuff that you'll no longer be able to restore to. So there's a bunch of work. That part of the work hasn't been done, but it's in the plans. There was a question here. I'll get to you in a sec, sir.
So technically, I can have multiple versions running at the same time of the restores.
So the question is, technically, can I have multiple versions running at the same time? Not exactly. Technically, you will have your entire history of the data because we only allow one instance to connect to the remote at any point in time. So you can only have one running at any point in time, but you can switch to whatever version. It's up to you, wherever you want to go.
Usually when you do deep restores, you actually need to restore specific transactions.
Correct.
So you need to restore the database in different layers, the timestamps, and you have to pull certain transactions.
Yep, so if you needed to go, the comment was usually for deep restores, you need to go to different points in time and it'll pull whatever you need and go jumping back and forth. But the really cool thing is if you do need to have multiples of these concurrently, you can restore to a second machine and basically do a snapshot of the remote. So that will allow you to have concurrent point in times of the others, but that implies that your local, you have the ability to host another copy of the database. So if you want to do that, when we get around to implementing snapshot on the remote side, so the snapshot, it's copy and write, so, and because we don't ever write on a remote, only inserts, then yeah, the cost is trivial. So if you really wanted to, you will be able to implement as soon as we get the code for the snapshot parts written. So there was a question here, sir? That's a really good way to put it. A local restore is non-destructive of the cloud versions, yes. There was another question. Yeah, sorry, the lights are in my face.
So this fetch table, does it complement the in-memory operations? So I have the hard data stored from in-memory, and then the archive data is
So let me try and paraphrase that. Will StretchDB work with the existing in-memory technologies? And is it complementary? Is it parallel? How do they fit together? Okay, so yes, it will work. Right now, we haven't done all the tests, so it's released as unsupported for those scenarios. There are a bunch of things. When you get CTP 2 bits, you will see that, oh, these things are unsupported. It doesn't mean that they don't work. It's just we haven't had enough time to go test all of them. But the idea is, yes, it will work. And the really cool thing there is, think about the generations and temperatures of your data. So the really active stuff you're going to keep in memory. That's really hot. And then the stuff that's kind of warm and whatnot, you can pop them into your local SSDs, and then stuff that's lukewarm will sit in your SAS drives, and the cold stuff, you can pop them into Azure. So you now have multiple generations of these things, and depending on how frequently these things are accessed and whatnot, then your cost and your latency and retrieval, all of that will be predicated on stuff that's common way up there in the expensive DRAMs, and then stuff that some auditor comes in once a year or once a quarter, they'll go to Azure. Any auditors in here? No? One auditor, or you had a question? Okay, I've been making comments about them, so people don't get mad at that, but it's a tough life, right? I mean, I've been there when auditors come in and you're the DBA, but I know auditors, and it's a tough life, and they need to get the data. Sir, question?
So on an existing table, when you do the alter and set remote data,
Enable remote data archive, yep.
is it in the with clause, or do you specify, let's say, date range?
So the question was, when you enable archive in a table, where do you set the with clause for predicate-based stretching? So it will be in the with clause. So today we only support on and off, and we only support the table-only stretch. Sometime post CTP2, we will ship updates that will support predicate-based stretching, and it will be a with clause. So let's kind of wrap this up. We're getting pretty close to the hour, so we just got one more portion to cover on the slides. So this is the last part. So how many of you actually actively use SQLDB today? Azure SQLDB? A handful of you? Okay, so maybe you didn't know this. The maximum database size today in SQLDB is 500 gigs. It will be raised in the near future, and we will continue to raise those numbers. But then you think about, okay, 500 gigs, how can I put tens of terabytes? But even if the largest database size that SQLDB supports is a petabyte, do you really want to go back to the same problem of having one massive database that, okay, you don't maintain, then we don't want to deal with that problem? So as with anything in cloud, actually most modern computing today, we're looking at distributed architectures, and this is no different. So we haven't decided what the numbers are. It probably will be some algorithmic approach so that we figure out what's the optimal fill factor per database. But as you move data to the cloud and you occupy the database and it reaches a certain capacity, then we will automatically spin up a new version. And as that goes on, just think of this as like the Coke bottling scenario, except that we decide how far to fill the bottle before it moves along. So think of your database as the Coke bottle, and we fill up to whatever we think is an optimal number, and we already have a second bottle waiting for you, and then you just keep flowing, and we just keep moving that along. And we manage the back end. The sharding of these multiple databases will be completely transparent to you. Again, as far as you're concerned, I'm hitting this one database that's sitting here on my on-prem site. If I don't like things, I lock it down. I effectively lock down the back end also. So the key thing is we want to mask the complexity away from you. That could be fairly complicated to go manage. Imagine if you have 50 or 100 terabytes out there. Even if you have it on-prem local, it's a lot of work to manage, and we want to figure out, because we have teams working on things like ElasticScale and PDW that really know this cluster technology and scale out databases extremely well, and we want to take advantage of those technologies. So you can, as far as you're concerned, come back. This is my one database, and we can grow as much as you want. And things that are not active, databases that are basically have been filled up, but nobody's querying them, you pay the storage, which is trivial, pennies to the dollar. Only when you need to query them, then you start paying for compute. So that's another thing that we want to make sure that you get a lot of value out of. Don't buy a bunch of stuff and pay for it, but you'll never use it except once or 6 times a year. So, summary, the whole idea of StretchDB, again, remember this whole stretch concept. We're not moving your entire database and telling you to repoint your applications. We're saying that your table, your database will look exactly as it did before, and your queries will run the way it's supposed to prior to stretching. In the initial release, we are targeting archive tables and mixed, basically predicate-based stretching. CTP2 will have archive tables capabilities, and shortly after that, we will have predicate-based, so you can tell us data that's older than 2 years, and we will stretch that. So these are the core things that we are working on, and hopefully this is going to be something that's useful to you. One thing that's very helpful to us is if you guys could really look into the TAP program. If this is something that's applicable to your scenario, you're dealing with these kinds of problems today, we'd love to hear from you. Kathy McDonald is in the booth. She runs our TAP program, or you can talk to me also. We'd really like to get you guys on board and maybe be early adopters, or at least help us test things out so that we can learn as many schemas and as many types of queries as possible, so we know what else we need to teach the query processor to do better at. So things like that will be super helpful. We'll make your workloads run better. Try CTP2 in summer. If you join the TAP program, you will get our incremental bits. So basically every month we have revs for our TAP partners. So they work with us closely, and they partner with the engineering team so that you have somebody that will walk you through every step of the way. If that's too high load for you guys, I perfectly understand. Look for the CTP2 in summer, and please do give it a try. Let us know what you think. With that, we have exactly 8 minutes for questions. So if you have questions, feel free to stay around. I will stay as long as necessary. Those of you who don't, I do understand that it's late, so feel free to find your ways home. And do remember to complete the feedback. Thank you very much.